Four charges with charge positive capital Q, negative capital Q, and negative Q are placed at the corners of a square of side X, as shown in the diagram. Which of the following represents the magnitude of the electric field due to the other three charges at the location of the negative Q charge? Right away, we take into consideration that Q is not going to be in any of the formulas, because the field is independent of the magnitude of the test charge. Whatever expression we have for the field at the location of Q depends only on the magnitude of the other charges, positive Q. According to the version of Coulomb's law for electric field, the field vector due to each of the negative charges has a magnitude of KEQ over x squared. One of the vectors is directed to the left and the other is directed down. On the other hand, the field due to the positive charge has a magnitude of KEQ over the square root of 2x squared, which is equal to KEQ over 2x squared. Since this field is directed at an angle of 45 degrees above the horizontal, the components of this field vector are each of magnitude square root of 2 KEQ over 4x squared. Because of the sign of the charge, positive Q, the directions of these components are up and to the right. Therefore, the resultant field has a horizontal and vertical component of magnitude 1 minus square root of 2 over 4 times KEQ over x squared. In order to get the magnitude of the field vector, we need to use the Pythagorean theorem. Due to the algebraic process involved, the product KEQ over x squared is just going to be copied at the end. The important part is the value obtained by the squaring and adding of the coefficient, 1 minus square root of 2 over 4. Simple algebra will tell you that this amount basically means multiplying the coefficient times the square root of 2. So we have square root of 2 times 1 minus square root of 2 over 4, which is equal to the square root of 2 minus 1/2, or 2 square root of 2 minus 1 over 2. When you multiply the coefficient times KEQ over x squared, you get the answer in option D.